Hi, Austin. I started to type out an email to answer this question, but it was getting a little bit complicated, so I figured a video would be a little bit easier. In question number 4 on homework 2, you're asked to find the area of the region in the first quadrant, bounded by y equals x to the 2/5, and y equals 3. So y equals 3 is just a horizontal line. And you can graph y equals x to the 2/5 on your graphing calculator, and you will see that it looks kind of like that. So we're talking about this region right here. You can really integrate this from top to bottom, which would be with respect to x, because when you draw a line from top to bottom, it points at the x-axis. So you can do it this way. Since that points at the x-axis, that means we're going to integrate with respect to x. We need to know the bounds in the x direction, how far left and how far right this graph goes. So since we're staying in the first quadrant, it is bounded by 0 on the left. On the right, that bound is where y equals 3 and y equals x to the 2/5 intersect. So when they intersect, that means they're equal. To solve this for x, you need to apply a power to both sides that will cancel it out. And since one power to another power is multiplication, we want to multiply to get a 1. So you're really just multiplying by the reciprocal. So this is going to be 3 to 5/2. So one of the questions you also asked was, how do they get this in radical notation? So the way that I would write this in radical notation, instead of using the calculator and getting a decimal, 5/2 is the same as 2 1/2, which means we really have 3 to the 2 1/2 power. So 3 squared is 9. A half power means square root. So I also have square root 3. So 3 to the 5/2 power is equal to 9 radical 3. And it's usually easier to see that if you change your fractional power there into a mixed number. The whole number part is an actual exponent. The fractional part means a root. So if we do this in terms of x, our upper bound is going to be 9 root 3, which is probably not going to be very nice. But the other thing I want to point out really quickly is to figure out the bounds, when you draw that vertical line, I know I'm going to integrate with respect to x because it points at the x-axis. The top function is the function that it passes through first, which is 3, and the bottom function is the function that it passes through second. So that's x to the 2/5. So minus x to the 2/5. So this is one way you can work it out. Because we got that really ugly bound of 9 radical 3, it's probably going to be better to work this one sideways instead. So I'm going to redraw this just so that graph there doesn't get too messy. Exact same graph. We've got y equals 3. And we've got x to the 2/5. So there's our region. But if we're going to integrate this with respect to y, that means I need an arrow that points to the y-axis. Everything within our integral is going to be written in terms of y, since my arrow points to the y-axis. So my functions need to be written in terms of y. I'm going to integrate with respect to y, and my bounds are going to be y values. So when you do it this way, you want to know how low the graph goes, which is 0, and how high the graph goes, which turns out to be a much nicer number of 3. And then when you follow this line into the y-axis, the y-axis is an actual bound, which is nice because that's just x equals 0. And then this function here, we also need it written in terms of y. Instead of having it as y equals x to the 2/5, we need to solve that equation so that x is the output and y is the input. And we're going to do that exactly the same way that I just did up here. If we want x to be all by itself, we need to get rid of the 2/5 power. And the way we do that is we apply the reciprocal power to both sides. So those just multiply to be 1, and your new function is x equals y to the 5/2. So when you follow this arrow in, the first function you hit is y to the 5/2, and the second one you hit is 0. So you can say minus 0, but technically minusing 0 doesn't do anything. So all we end up with is the integral from 0 to 3 of y to the 5/2 dy. So all we have to do is a power rule on that. So you add 1 to the exponent, and then flip that exponent for your new coefficient. That would be our antiderivative using the power rule, and we evaluate from 0 to 3. If you plug 3 in, we're going to have 2/7 of 3 to the 7/2. And then if you plug 0 in, you're going to get 0. So again, it looks like this is where we're going to have to do that little trick with our mixed number. So 3 to the 7/2. 7/2 is the same as 3 and a half. So we want to cube the 3, and then we also still need a square root. So cubing 3 gets 27. So I've got 2/7, and I've got 27, and then 3 to the 1/2 power is a radical 3. And we can clean this up a little bit kind of just by multiplying this stuff into the numerator. So we get 54 radical 3 over 7. I hope that helps. And if it doesn't, just email me back and I guess clarify a little further if what you needed wasn't in here. And I'm about to answer your second question.